I'm going to run through some code for reproducing a table found in Rosen's elementary number theory, table 3.1. It's all about the distribution of primes. And so I got this code out of ChatGPT, and I'll put the exact question that delivered it in the comments for this video in the description. And so this is some the various tests that I did to make sure everything was working. The imports are also going to be in the video description. Then I tried also some tests just to make sure everything was running. Then created a pandas and ran the for loop. And I'll just show you the table very briefly. It's going to be a very brief video, but I just wanted to show you all that when you run the code to count the number of primes up to a certain number, count primes, that's the actual raw number, the correct number. So it's 25 primes up to 100. Then when you use the x over log x function, you begin with an underestimate, 21.7. And then when you use the logarithmic integral, you have an overestimate of 30.1. But as you go to higher numbers, so how many primes are there up to a million? There's exactly 78,498. The x log x is going to give you 72,382.4, and the logarithmic integral is going to give you 78,627. So yeah, definitely the logarithmic integral gives you a much closer estimate of the total number of primes. But as you can see, the number doesn't get much bigger, continues to get smaller and smaller as you go to larger and larger numbers, because you're getting a lot more composite numbers. Anyways, I'll end here. When you run this code, and I'll put it in the comments as well in the description, be careful adding additional rows. So if you add the 10 million and the 100 million and the 1 billion row, it's going to take a long time on a laptop. Just be forewarned.